Wind energy is one of the fastest growing energy sectors in the United States. Part of the challenge of choosing best sites for wind energy development is understanding where the best resources might be found across the United States. Using WEAVE, we are able to look at data provided by the National Renewable Energy Laboratory to examine how wind energy resources are distributed across the U.S. The data used to generate this visualization comes from a June 2010 report by the National Renewable Energy Laboratory titled Assessment of Offshore Wind Energy Resources for the United States, as well as data provided through the Department of Energy's Office of Energy Efficiency and Renewable Energy. Both are publicly available. Land-based resources are for the 48 contiguous states. Offshore estimates have not yet been updated for the states of Florida, Alabama, or Mississippi, so data for these states cannot be included. The coastal areas shown represent the administrative areas of individual states, from about 3 nautical miles out to a distance of about 50 nautical miles. Each state is currently colored according to the aggregate amount of offshore and onshore wind resource available in megawatts. I chose blues because it shows some of the changes in gradients more clearly. Texas is the clear leader with over 2,179 gigawatts of wind capacity possible according to the estimates. We can select a different variable to get a better look at what the offshore and onshore values look like when they are disaggregated from each other. The National Renewable Energy Laboratory estimated 4,150 gigawatts of wind offshore and about 10,500 gigawatts onshore, for example. So it is not surprising that the offshore areas appear lighter. I can also use a prepared subset to show that many of the Atlantic states lack a large onshore wind resource but have potential in their coastal areas. We can then add each of the records back into the dataset and make selections using the histogram. First, I can remove the state of Texas from the map, since its wind resource estimate is so large relative to all other states. Now when I select bins on the histogram, notice how offshore areas start to pop up here and there. Many states that did not appear to have much wind resource compared to Texas, in fact, have a large offshore resource. I am highlighting this by showing the low bin and then moving to the middle bins. By zooming into the Gulf of Mexico region and adding a new point layer, this one from the Bureau of Ocean Energy Management, Regulation, and Enforcement, we can look at the location of some of the United States offshore oil rigs, of which there are over 4,000. Here I have them colored a brownish color. Many of these oil rigs can be found at a distance well over 50 miles off the coast of Texas or Louisiana. There is a lot of oil drilling activity in federal waters that extend beyond the boundary used for offshore wind resource jurisdictions. This is because the offshore estimates only include areas generally between 3 to 50 nautical miles offshore. The United States offshore boundary extends out to a maximum of about 200 nautical miles. I will now remove that geolayer and add a new one from the Federal Aviation Administration, which is based on obstruction evaluations performed for wind turbines between the years 2000 and 2011. I colored these points a dark blue to contrast well with the map and distinguish them from oil rigs. Each point represents a wind turbine standing over 200 feet, which the FAA tracks in order to protect the quality of radar coverage across the United States. This data includes both proposed and existing turbines. Zooming in, you can see the layout of the planned Cape Wind offshore project, the first offshore wind project likely to be completed in the United States. Over 90,000 data points are displayed at the moment, but like other shapefiles, I can select subsets if I need to. Zooming back out, only the subset I have selected is displayed. Along with wind energy resources, we could start considering the planning that might be required to harvest these resources.